Hello. Hello. Ah, hello, Soha. Thank you. Hello. Hello. That's awesome. Thank you. Hello, Rachel. Hello. Hello, Makayla. Hello, Kaneza. Hello, Veronica. Hello. I love this part. Hello, Kellyanna. Hello, Lars. Who else we got? You, yes. You, oh, and hello. Oops, sorry. Hello, Jasmine. Hello, Kameza. Oh, cool. Hello, Rahel. Oh, and good afternoon, Crystal. That's nice. I like that. Oh, hello, Veronica. I'm sorry. I missed Skyla. Hello, Skyla. Hello. And did I say Rachel? Hello. And if I did, I apologize. Hello, Veronica. If I said hello, Vanietta. Hello. Oh, it's weird how it comes up. Okay. Hello, Jasmine. If I didn't say that. Hello, Gabrielle. Hello, Syed. Syed. Oh, and there's more. Sorry. And this class is always amazing. Okay, more people come. Uh, uh, hello, hello. Oh, more people. God. Okay. Okay. Hello. Oh, hello. Oh, hello. Hello, Quasi. I love it. That's awesome. Thank you. That's awesome. Okay. Hello, Jennifer. Hi. That's awesome. Oh, wait. Who else is it? Wait, and I say Quasi, right? Oh, hello, Iola. Awesome. Awesome. Okay. Hello, everybody. Okay. So we're here. Let me, okay, we're going to start. What am I doing? I'm doing this. Okay. And right. Oh, wait. Oh, oh, that's interesting. One second. Okay. Cool. I'm just answering some things in the private chat. Some good questions coming up in the private chat that I will try to address later to everybody, but anything I'm getting in the private chat right now, the answer is yes. I mean, very good questions, but I'm not going to get involved in the discussion about them right now, but yes. Okay, cool. So we're going to get rolling in a second. We have some items of business. I love this class. I hope I've mentioned, I really do love this guy. I think you guys are great. And now I feel terrible about something that's actually a snafu on my part. I mean, hopefully it's not a big crisis, but you all, a huge, you got the homework number 3, I signed it, and a huge number of you turned it in. Like almost all of you turned it in, and many of you a while ago. And I totally appreciate that. And I missed that fact. I actually thought I was coming here today having graded everything that ever came in all the classes, and I thought I was, but I tried to, it's not interesting why, but I totally missed the fact that yours had come in when I went to, because I was going by notifications, not by another, no good reason, but I know that tons of you have turned in the unthingy things, and you absolutely are going to get credit for them. And you're going to get them back, and we are going to go over and talk about them today. But if you turned it in, I know you did, and I didn't get it back to you, and I apologize. I actually didn't. Anyway, it's an oversight, but you'll get them back. You'll get the points back. Content-wise, we're going to talk about them in a big way today. Hopefully, it'll be kind of fun and a little bit of a break from some of the mathy things we've been doing. We're going to do that in a minute before we even get to motion 4, motion 5, or anything. So we're going to go over this unthingy thing business. Again, if you did do it, I have it and I know it, and you can have your copy in front of you while we're talking about this. You just haven't gotten the points yet, and I apologize. And it doesn't, and especially with this homework, if you did it and you did it fully, like even if we say some things in class today that then make you think that you said other stuff, this is even less than usual about right and wrong and stuff like that. So if you actually answered every question, you'll get full credit, and don't worry about changing anything or anything like that. Long way of saying, in a minute, we're going to go over this unthingy thing business. And I just, as usual, I just kind of want to emphasize, hopefully it's not meant to be a waste of your time, whether you did it or didn't do it. Hopefully you can get something out of this discussion. You'll get more out of it if you've already thought about the sheet. you'll get more out of it if you've already thought about the sheet, but you should still be able to follow even if you didn't, and it shouldn't be a waste of your time if you did. Okay. That's that. So we're going to go to unthingy things in a second. But there's one dangerous question I have to ask first also. Do I really want to ask this? Let me think for a second. Okay, yeah, because Walters and I have been talking in the background, but we haven't resolved something in the background. And I know I go first in the week and then he goes on Wednesday. So let me just check. Has there been any discussion in your last meeting with Walters? Has any of you discussed anything about, say, a midterm exam? Has this come up? I mean, so I'm looking at, has there been any mention of a midterm exam? And you could be on, well, anyway. Okay. I think the answer is no also. Okay, no, cool. I'm not trying to put you on the spot. I think the answer is no also, honestly, because he came to me and we realized it's time that we want to actually schedule one before you all get itchy or get panicked about it. So I didn't think you had discussed either. Just want to make sure. Okay. And you're definitely, all right. So let me give you a brief thing about the midterm exam. I don't want to spend this whole period on it. And I'm bringing this up. I'm trying to bring it up before it starts worrying anybody, before they think what's happening. It's not to make anybody worried or anything like that. But the way we do midterm exams in this class, we'll give you a lot of details. The way we do midterm is the same way we do the final, which is that we will give you a practice exam first that you will take on your own time, that we will discuss in class after you've taken it. You will take not necessarily under test conditions, and you'll take it more than once on your own time. But the way like a midterm exam is going to come soon. We're gonna have to have a midterm exam. It's going to be after break. Okay. I'm pretty sure someone might want to put in the chat and remind me when break is. But if I'm remembering correctly, like you're not having this exam before break. Oh, thank you. Break is the 27th. Okay, thank you. Let me look at that right now. Okay. Yeah. Okay. So right. So we have one more week. So the truth is, right. There's no way this. So in other words, to be clear. Right. Exactly what Jesse, and thank you. That's very concrete. What Jesse, well, first of all, thank you all. Thank you all for responding, and thank you, Jesse and Quasi, for putting the break dates into the chat. But it's exactly what Jesse said is actually the most concrete, important thing. If the exam is not next week, then it has to be after break. And I'm saying right now, I'm bringing up the exam right now. It is not next week because we wouldn't do that to you. We would not give you an exam with only 1 week notice. We're not into surprises. Okay. In fact, so here's how it's going to work. The way we do exams is we always how much do I want to get into this right now? Yeah, we will nail down the actual day. I will talk to Walters tonight or tomorrow, and then you'll see him Wednesday. Probably by Wednesday, we will all, in one way or another, have nailed down the exact date for the exam. But here's what I want you to know what it looks like when we have an exam. This is what it means to nail down a date. Let's say, for example, that we decide that the midterm exam, let's say that we decide that it's Monday, and it will be a Monday because that's when we meet as a lecture group. Like, let's say we decided, hold on one second. That our exam, let's say we decided that our exam is Monday, the 18th of April. And by the way, maybe that is what we're going to, like, that wouldn't be an unreasonable thing to decide. Let's say we decided that our exam was Monday, April 18th. And again, you have a midterm exam in this class, and then you have a final exam. You don't generally have 2 midterms. You have generally 1. So let's say the midterm is Monday, the 18th. What would that mean? What would that look like? Like, what type of exam is it? Blah, blah, blah. Well, a couple things you need to know about it is that if the exam is Monday, the 18th, what that means is that like something like the Wednesday prior or the Thursday prior to that Monday or something like that, we would post the exam itself in Google Classroom as though it were just a really long homework assignment or something, okay? But it would be worth 100 points and all that. But we would post the exam in Google Classroom approximately 5 days prior to the actual exam date. And you would have 4 or 5 days or whatever to take the exam as a take home, untimed, untest conditioned exam. Like it's a take home document. It's kind of like a history essay or something like that. Like it's like a big paper, if you want to think of it that way. Like it's an exam that has questions that you answer that, you know, it looks like homework, but you have time to answer them. You're given time, you answer them at home in your own way. And then what if the exam is, if we say the exam date is Monday the 18th, that would mean that you have to turn in the thing electronically by Google Classroom, like as though it were just a big homework assignment. It's like one of the reasons we practice turning in homework and stuff like that, just to make sure there's no issue with that. If we're saying the exam is Monday the 18th, then that would mean that 2 minutes, like up until 2 minutes before class of that day, you would have to turn in your whole exam, all of your solutions, all of your work, all your diagrams, whatever. You would turn it into Google Classroom, and then I would grade it. So it's a take home document kind of thing. Okay. And then how would you know what to study? How would you know what's going to be on this exam? Like, how do you prepare for it? Well, what happens is a week prior or so, prior to even the posting of it, a week prior to that, we post a practice exam, which will be very similar to the actual exam, like deliberately, like no tricks, like deliberately extremely similar, not identical. Of course, like some numbers will be changed to protect the innocent. Some parts of some problems will be changed to make you think and stuff like that. But by and large, like 80% of the exam will be identical. And certainly all the format and the type of topics covered and all that will be deliberately close to identical. I mean, they will be similar. So instead of giving review packets and review explanations of what chapters to study and this and that, what we do is we just give you a practice exam, which is taken from old exams. And you're also welcome. Any old exams you ever find, because you have an older brother or an older sister, whatever, or an MSRC or tutoring, any old exams that we've ever given are totally fair game. But because we don't want one person to have an advantage because they have 85 of these old exams and another person doesn't, we just right away give you one of our old exams as a practice. I mean, whatever. We give you a practice exam. And again, if say our exam were to be on the 18th, is that what I said? If hypothetically our exam is Monday the 18th, that would mean that somewhere around like Monday, you know, before Monday like it means that you will have had a practice exam that you'll have a week to work on. Oh, sorry, people are here. Sorry, hold on 1 second. What I'm trying to say that I'm oversaying as usual is if I say there's an exam in this class, what that really means is 5 days prior to an online exam is posted and you have like 5 days to do it on your own untimed and turn it in. And what that means is like a week and a half prior to that or so, we online post a practice exam that we at least have at least one class period where you can answer or ask questions about the practice exam and stuff. And we talk about it. Oh, and I'm sorry. And somewhere in there, we post a bunch of solutions to that practice exam. It might not be right at the moment. Like right at the moment we post the practice exam, there might not be any solutions in it at first. Like you have to work through it, you have to study, practice, blah, blah. But somewhere in there, we give you solutions also, just so you can see what's going on. So the way you study for our exam is it's like it's SATs. You just practice taking the exam itself, and you practice with solutions that we give you. And by the way, we don't expect that any of this will be very hard. From what, like most of you have been very good in this class. It's pretty clear you know what's going on. I don't think you're going to find this exam. It's not meant to be super stressful, and it's definitely not meant to be surprises. The long and short of what I'm trying to say right now is we like you to know physics by the end. The idea is to know some physics, and you'll realize by then that you know some physics that actually is some hard physics. But the hard thing about our exams, hopefully, is just the physics. We don't like the idea of making a big mystery show. Like we don't, the whole idea of like that our exam will cover 3 things, but you have to study 100 things and you don't know which 3 they are. So we get you to learn 100 things by then saying you just have to like know all 100, but we're going to put 3 on the exam. And then you have a whole guessing game of what's going to be on the exam. That's not how this works here. And there are benefits to that, but it's not how it works here. How it works here is we don't want there to be mystery or surprise about what's on. By the time you get to our exam, we want it to be like a piano recital. Like you've just been practicing so many times. It's not about what am I going to play? It's about how well can I play it? Okay, really. And so all that said, we don't like to announce an exam. I mean, we do like to have flexibility each semester and not lock ourselves into an exam time months in advance because we don't know how the students are going to be and stuff. But now that I know you and Walters knows you and stuff, it's coming to the exam time. And what we're saying is we need a solid 2.5 weeks or so to do an exam the way we like to do it, which is to have practice first and really just like know by the time we take the exam, it should be within your power to get an A+ as long as you've like done everything. It should be within your power to do that without a big mystery. So all that said, I think with Walters on Wednesday, I'm going to check in with Walters. Hopefully by Wednesday, we'll nail, like either you as a group or he'll come with a suggestion to you. Like he'll say like, I think the exam should be Monday, the 18th. Can we all approve this now? Or you'll give him counter suggestions or something, but it's going to be something like that. Like your exam will be around, I'm basically proposing it's good. It will be after break. We don't have time before break. I'm definitely convinced of that. Having heard it will be after break. It won't, but you need time to have a practice exam and look through and ask me questions and stuff. So I'm thinking your exam is something like Monday the 18th, but whether it's the 18th or the 25th of April, kind of you can negotiate that with Walters on Wednesday, or I'll ask him in the background if he's got feelings. But it's looking like that. Does that, and again, because we'll do all that, because we'll give you a practice exam, because we'll give you solutions, because we'll talk about the practice exam, I therefore don't want to like spend all of today dealing with this, but I just know the time is coming and Walter's asked me. So I think what I'm just trying to do right now is give you a sense of what, and when I say practice exam, I mean literally like the practice exam you're given will have an equation sheet on the front. That will be the exact equation sheet that you'll have in your exam. It'll have like problem 1, fact pattern, and ask you about, and that'll be exactly like, it literally is, so that there's just no sweating. Like, so that by the time you get to the real exam, I'll tell you this, when you get to the real exam, anything that looks different at all, if you're like, oh, question 1 originally had like pi in it, but this has 2 pi in it or something, wherever you see differences at all, don't assume they're typos and don't get freaked out and don't be like, wait, but I studied pi, now it's 2 pi. No, that's where you want to focus the most. Whatever 15% of differs from the actual exam, from the practice exam, that's of course where we're saying now, like make sure you know all these concepts well enough that you can tweak the concept under this new number or this new application. So you want to kind of spend your most time in whatever is a little bit different. But by the time you've studied the practice exam, that should be, 2 people in the waiting room. Sorry. That should be like not a problem. All right, wait. So all that said, exam is in the air. I felt I have to address it. That's my addressing of it right now. You can still ask questions right now, but does this make any sense? Are people with me? Do you sort of get what I'm saying? Yeah, thank you. Oh, cool. Okay, wow. All right, great. Thank you, Gabrielle. Thank you. Sorry, wait. Thank you, Jennifer, and thank you, Rahel. Great. Okay, so I'm going to listen. So, if that's true, we can go to this unthingy thing. Even though I know that last week we talked about motion 4 sort of, and then you've even had a class in. Wait, you had a class in. I know there's another motion we have to catch up about, but I want to. Yeah, but nonetheless, I'm going to go to the unthingy thing for a moment. So I'm going to take that out. Again, whether you did it or not, I'm going to take out the unthingy thing sheet. We're going to sort of share our results and talk about it right now. Give me a second to take it out, but you please too. Hold on a second. Oh, actually, I guess I can. Hold on, I wonder if I can do it this way. Well, oh, right. So how much time you'll have for the exam? You'll have a lot of time. Like if you will have something like that. Sorry, so I'm just reading. So the question is, Professor, how much time would we have for the exam? Well, if the exam is due at 4:30 p.m. on a Monday, the exam will probably be posted my guess is Thursday night, maybe Wednesday night, but probably Thursday night. So like it'll be posted starting around 8 p.m. Thursday night. Again, we'll tell you more specifically as we get closer, but probably like Thursday, 8 p.m. And then it'd be due 4:30 Monday. And what we're saying is it's not a timed test. Like you can work on it for any and all times over those 4 days. I don't know if that answers the question, but it's not a timed exam. Like this is not a test conditions kind of exam. You're not going to sit with a clock or with, oh, okay, cool. All right, cool. And hopefully that will make it less stressful for a lot of people. Now, I took a lot of take-home exams in college as a physics major. A lot of exams like this where they would, we didn't have the internet and stuff like that, but I mean, they would distribute, we would come to class, they would distribute an exam like with blue books, like on a Thursday, whatever. And then they would send us, we'd go to our dorms and have all weekend to do this thing and then come back and hand it Monday. And in a way, of course, that was great that I didn't have to sit at a desk and like and sweat bullets under the time. I mean, the time pressure really gets me. I don't know about all of you, but I do not work well under time pressure, even though it's the only way I work also. But these untimed exams, they're much more comfortable in a way. They allow you to really think through the physics, but of course, they're also super stressful in the fact that they never end until you turn it in, right? So everything's a trade-off. But yeah, it's an untimed exam. You have full weekend to do it. That is definitely the answer to that. And we'll get into also what resources you're allowed to use and stuff like that. We'll have that discussion. Like, are you allowed to turn on your internet while you're doing this? Oh, that's an interesting question. And the answer is yes. Oh, no, not this way. Oh, sorry. No, not this. Oh, right. Some people are coming in late. No, everything I'm talking about right now. Oh, wait, sorry. Yeah. Okay, wait. So first of all, I'm with Quasi. Like, yes, no, time pressure is bad. We can have a whole discussion about this too. It's one of the reasons that I praise you guys and tell you it's going to be all right in this major and don't lose faith, because the stress can be stressful. And believe me, you could see the way I teach, I was not a model like student. I mean, in some ways I was a successful student, but I'm not good at this stuff the way some of you are, studying and managing time and like coping with stress. Not my strengths. My strength was something else. And I had to compensate a lot for, just like some of you. So I get it. I mean, wait, so yes, time pressure, I don't like it. I don't want it for you guys. I mean, sometimes it's necessary, but I don't want to introduce it when it's not necessary. Also, it's just like dumb with Zoom and everything. Who are we kidding? Really? I mean, I don't know what everybody's thinking, trying to, enforce. Well, it's a whole other discussion, but the idea of you guys taking a Zoom test in front of me while I proctor it, like, is so insane. I don't even, but, yeah, no, there's a lot of reasons why. But let me say before I get any crazy, because I know some people just joined us because some people are having Wi-Fi problems, whatever. Everything we're talking about the midterm right now, to anybody, whether you're tuning in right, this is going to be about after break. We're talking about it now because I want to nail down a date for you so we don't have anxiety, and because I'm in communication with Walters. We're talking about exams now because a midterm is coming up. There will be a midterm, but it's going to be after break. I'm guessing, again, for anybody who's just tuning in right now, I'm guessing this midterm is looking like a good date would be Monday the 16th. I mean, Monday the 18th is what I'm guessing, of April is what I'm guessing. That will be firmed up this coming Wednesday with Walters, but I'm guessing Monday the 18th. But again, but yeah, it's not now, no matter what. It's just coming. LOL. Okay, I don't even know what the LOL is, but okay. Yeah. Okay. But one of the reasons, look, exams are unnatural and stressful as it is, but an exam on Zoom that's timed and being proctored by a webcam is so unnatural. Of course you get stressed. Like, I'm sorry, like whatever anybody's beliefs are, I do not think that an electron on the top of Mount Sinai handed 2 tablets to Moses and said, and by the way, administer exams on Zoom while you're at it as well. Like, I don't think it's heavenly ordained that we have timed exams on Zoom, even if Zoom itself is heavenly ordained. Like, it's just too crazy and unnatural. Of course it's stressful. Yeah, I hate it. I would hate it. I would hate it as a professor. I don't even know how these people are doing it. It's crazy town. Yeah. Yeah, look, facts, right? Facts. I love that. I mean, and don't get me started, or do get me started. I could literally rant about this for 2.5 hours, as I'm sure you guys know. I could rant about it, but look, Well, and we will talk about these issues as we get closer to your exam, but you'll see what a crazy philosophy Walters and I have when it comes to cheating and all that kind of stuff. Like, don't believe me. I know that cheating is a thing. I know it's a thing. I think it's a bigger thing than some of the people that are anti-cheating think it is, but I think their definition of cheating is all wrong. That's what it comes down. I mean, we'll get into this, but like, I think cheating is terrible, and it's terrible. It's like so dumb, and it's like stealing from yourself, and it's like it is like stealing from yourself. It's something that is worse than money, but it's cheating is between you and yourself and your God. Like, there's so many ways to cheat that other people will never know. And there's ways to think you're not cheating when you actually are cheating. And there's it is not actually like up to me to decide whether you're being honest with your own brain or not. Like, actually, it is up to me to decide. I decide every minute whether you guys are, but it's not up to me to enforce. And I will judge all the time whether I think people are being honest in their own brain, but that is not up to me to actually do anything about, or to like, I know it's another discussion. We'll get to it, but all right. Wait. Oh God. Oh yeah, actually, okay. Kat's reason for why being stressed during a Zoom exam is a lot more concrete than anything I just said. Yes, that's probably more the reason. All right, but okay, so your physics exam time as such is not going to be an issue for whatever that's worth. So we'll get to that. But now I want to talk about these unthingy things. So bear with me for a second while I bring up the sheet. And talk, this is like the opposite end of the spectrum. As stressful as exams are to me, if there's one thing that is fun and not stressful to me, it's talking about unthingy things. And especially if you know in advance that you really like can't really be wrong about this. It's a fun thing. Okay. But again, I am apologetic that I didn't grade your things. That is totally an oversight. I totally messed that up. But we're going to, okay, here comes a sheet. Okay. You were asked, okay, so here we go. You were asked to clear everything on your desk, and we were asked to do this. Like, hopefully you did sort of try to do this sort of. You were asked to clear your desk and identify two objects and call them like thing one and thing two. It could be a pencil and a cell phone, could be whatever, a pencil and a Coke. And then you were asked to do a bunch of weird things with the two objects. And ultimately, it's so that we can have a discussion and make a point about it. But before we go any further, there's a couple of like modifications or qualifications. And one is, the first thing is a bit of a technicality, but we sort of have to get it straight before we go any further. It asks you to identify, or to play. It keeps referring to the center point of thing one or the center point of thing two. Okay. When I refer to the center point of something, I mean like a Euclidean point, like a dot, like a particle, like a location of infinitesimal volume, right? When I refer to a point, that is what I do mean. A region of infinitesimal volume of zero dimension, right? That's what I mean by point. And from here on in, at least with this exercise, when I consider an object, when I talk about, like let's say I decided that my Coke can was thing one, I'm asking that before I go any further, that from now on, if I say thing one, I don't really mean the whole Coke can. I want to say from here on in, when I say thing one, what I mean is a Euclidean point, like a representative dot at essentially the center of the Coke can. Like I mean some little dot of Coke that is kind of representing the whole Coke can. Put another, because I want to talk about where this Coke can is in space and time. And then the thing is that even a Coke can is fairly large, right? Like a Coke can, if I say, where's the Coke can? Well, it's taking, I mean, the top of the Coke can is in one place in space and the bottom of the Coke can is in another place in space, right? And even the molecules that it's made up of, as you know, from chemistry and everything else, like even a molecule has like atoms at the top and atoms at the bottom. So depending on how precise I want to be, and I kind of do want to be sort of precise in physics about space and time, if I'm going to start discussing where and when this Coke can is doing anything, I actually want to be more narrow and focused. So I'm going to imagine that. So I'm going to think of locations one point at a time, and I'm going to think of instants in time one instant at a time. And therefore, if by that reasoning, the Coke can, if I want to talk about what point in space it's occupying, the only fair way I could do that would be to pick a representative point in the Coke can, like say at the center, and talk about what that point is occupying. So in other words, whenever I move the Coke can around, sorry, I keep talking about this Coke can and you don't even see it, I realize right now, but if I'm going to track the motion of this Coke can, I'm using a Coke can because it's concrete and relatable and like it's in front of me and all that. But really, it's very oddly shaped and it's very large and it takes up a lot of space. So from here on in, whenever I'm talking about the Coke can, what I really mean is the point located at its center, truly speaking, its center of mass. That's the point I mean whenever I say Coke can. I mean the point at the center of it. And if I ask where is the Coke can, what I really mean is where is that center point? Okay. In fact, well, no, yeah. All right. So that's, I just want that in mind so that it's just a rule of conversation so that we're talking about the same thing when we're talking about it. Okay. That said, okay. Okay. That said. Okay. So here I'm just quickly just like writing down what I think the question is, right? The question of the sheet. And again, most of you already thought this through. The question gives you 5 tasks. It asks you each one to attempt, but it sort of warns you in advance. Each of the 5 tasks is very simple. It's so simple that it's either doable in a heartbeat or it's totally not at all doable, right? Each one is not, it's not a multi-layer task. Each one you can either sort of do or you can't do is what you're being told. And do or can't do according to your intuition, your most reasonable, generous reading of this sheet. So you're told in advance that some of these tasks are going to be possible, some are going to be impossible, and your job is to assess which one is which. By the way, side note, notice that what I try to do as a habit is like I've got my sheet, my question sheet over somewhere, like not on my computer screen, right? But I'm trying to answer the questions here on a separate sheet. Of course, I have to keep flipping back and forth just like you, and it's annoying and hard. But notice that on my sheet of answers or responses, I'm trying to sort of give my own little summary of what the question is, like right here while I'm solving with you guys. But I'm saying kind of as a physics student or as someone when I do homework, right? What I'm trying to do here, I'm not recopying the whole question and I'm not cutting and pasting it either. I'm just actually trying to take the question from the homework sheet and put it kind of in my own words right here as an introduction to my answer, partly for the reader's sake, so they know what they're reading when they're about to read my homework answers, but also partly for my sake, so I don't have to keep flipping back and forth. But also, if you attempt to put the question in your own words a little bit, it shows everybody, you and your reader, like me, it really helps you own the question. If you can just sort of step back and ask yourself the question in your own words before you even start answering it, it's a very good habit for addressing a lot of problems at once. Like it kind of anybody who does this in their homework, if they sort of put the question in their own words before they answer it, it really gives me a major clue right away how much they know what's going on or not. Like even if their answer is wrong, if they sort of ask the question first in their own words, I really know we're in a conversation, right? Okay, so that's what I'm trying to do here. So I'm going to now try to assess for each of these 5 tasks, whether it's possible or impossible, where you guys are, this we're going to talk about. And I'm going to try to be reasonable about this. Like we're going to have a debate, I hope. I mean, we like debates with Walters. I love debates. Hopefully this is going to get us into some disagreement or some fun, lively, like I see it different way. And I'm a big believer in that. And I don't think anything happens in science without that, but the best disagreements happen authentically, right? We're not looking to create disagreement. We're looking to discover disagreement. So in other words, when you try to answer each of these questions, when you did for homework, when you now do, when we ask, is each one possible or impossible? It's really, in fact, I'm even going to write this in a second. I want, and I think this class needs to hear this less than, like, I think you guys have a great attitude and I mean it. It's like really apparent to me. I think you really, and I know already from what you're doing with Walters, you guys do seem to know how to do debate without violence, if you know what I mean. And part of that is not just respecting each other, but it's actually respecting the world of ideas, so much so that when I ask, is each one of these possible or impossible? And even if we know going in, some of them are going to be impossible, otherwise it's not a meaningful discussion. Don't look to cause problems, right? Don't, like, if I say, is it possible or impossible? Try to actually tell me what you think is reasonably like the answer with the most reasonable interpretation of the question. Even if you could see how someone could see an exception, let them say it. Like, I don't want to overly warn you, but we're not looking to see how we're not looking to make something tricky. We're looking to make it reasonable and then see if it turns anyway. All right, that's a lot. So I'm saying, let's get to it. I'm saying task 1. I'm going to turn it to you guys. So task 1, it says task 1 was, task lowercase 1. Right. 2. Okay, so the very first question was, is it possible to have two objects? Sorry, is it possible? Sorry. That is correct, but I want to make room for one other thing, sorry. Actually, I'm going to go to the next page. Okay, task 1 is, can you take 2 points of mass, have them at 2 points of space at 1 point of time, right? That is task number 1. And so I now will finally shut up for the first time in a while and say, can anybody in the class either in the chat or physically or private chat, tell me yes or no, possible or impossible? And if it's possible, do a demonstration with your hands, like right on video if you can, or something. Like if it's possible, give me an awesome.
I said it was possible.
Awesome. Oh wait, and then and do it. Oh, and do it. Oh, awesome. Awesome. Wait, there's a minute. Great. I just got 4 people. Wait. So yeah, awesome, Lars. Awesome, Veronica. Awesome. Oh, this is great. Great. Oh, this is like everybody. Oh, I love this class so much. Yes, Kameza. Yes, Jesse. Yes, Soa. Yes, Kameza. Yes, Chris. Yes. All right. So you're all saying possible. And thank and wait, I can't even see. And then when I just saw, was that cat? Did someone just? I don't. Yes. That. Thank you. Okay. Right. Thank you. That. Okay. So it's insanely right. It's not meant to be a trick. And this is just like in exams. Whenever I ask something, if you think you know the answer and it turned out to be right, and if anybody's like, "Why did you even ask? That's so stupid." Like, obviously, yeah. If you're thinking like, obviously, yeah. Like, I don't disagree with any of you. And the demonstration Kat just did, when Kat was like, "Oh, yes, that's all I'm looking for here." But it doesn't. But the reason is, of course, there's going to be a contrast coming down the road. Like everything about physics is actually. Everything about physics is about the obvious, but it just turns out that the obvious stuff is like way more rich and productive than we ever might have thought. But yes, what I'm saying right now, I'm agreeing with all of you thus far. What I believe we are saying is this assembly, 2 points of mass, 2 points in space, 1 point in time, totally possible. Yes. And demonstrated just by when Kat or anybody else just went like this, like pencil and Coke. Same, 2 different places, same time. Yes. Okay. Nothing interesting maybe so far, but I agree. So whatever our definitions of space and time are that we're all working, we seem to be working with the same definitions here so far, or the same interpretation of this question. So now we go to task 2. Unless there's questions. Okay, task 2. And again, bear with me. This is all ultimately to make a point. So task 2 is now also 2 points of mass. But now this one is 2 points in time. One point in space. Right? Yeah, that's this one. Yeah. And I mean, in English, we're using words like different and same, but here I'm sort of intentionally switching those words to 2 and 1 to just try to make this as stark as possible. So now we ask, is it possible to have, oh, good. Yeah, you're way ahead of me. Awesome. Awesome. I love this class. Did I say that? Yes. Now, I think this one is, I agree with you. I think this one is also possible. I do agree with you guys. That is, I agree with Veronica, Skylar, Jasmine, Jesse, Kat, Gabrielle, Rahel. Sorry. Okay, and there is what? Sorry, it's not a total unanimity. I shouldn't jump the gun on this. There is some disagreement, and I also see some in the private chat too about whether this is possible or not. Now, and that's fair. I don't want to be weird, so I'll say, since I've already sort of, I actually do think this one is possible, but I do think it's fair for there to be a pause or a question, if for no other reason that I think the demonstration of this being possible is different from the demonstration before. Like before, a minute ago, when I kind of asked for a demonstration or whatever, Kat and other people and Kat went like this, and that was a demonstration of task number 1. 2 objects at 2 points in space at 1 point in time is this. Now, this is definitely now a different question. Like I do want to say, at least one person in the private chat questioned whether this one's possible, and at least one person I think in the public chat. So it's not crazy to question this one. This one is different. This one is asking 2 points of mass at 2 points in time, 1 point in space. So this is asking for a different thing. But it is true, I guess, because I don't want to like be weird. I'll cut to chase and say, like this one I think is possible because I think you can do something, and I know some of you are thinking that you could do something like this. Rant. Like, let me do that. Like you can go like rant and then rant. Yeah, right. Like I think this is what Veronica. Right. Like what Veronica. Right. Exactly what Veronica just said. Now I want to emphasize. Now I'm not trying to say we're trying to go somewhere with this. Again, to me, the most interesting things in physics are the things that don't seem like they're going to be interesting at first. Like that's actually kind of what it's all about to me. Here, I'm trying to move always from things that we know, we take for granted to get to somewhere that we don't. So I'm saying here, this second question, I think the answer is also possible. I think the answer is yes again, but for a totally different reason. Like we are being asked something different here. Here I'm being asked, can I take an object and put it at some space at some time, and then at some later time have a different object at that same space? And I think when I think about it that way, yes, I can. But that's, in other words, 4 plus 3 equals 7. But, sorry, in other words, if I ask you all, what's 4 plus 3? You could say 7, right? Then later on, I could say, what's 5 plus 2? Now, if it turns out that the answer is also 7, that does not mean I asked you the same question twice, right? Like it means that 7 has 2 different implications. 7 can be thought of as 3 plus 4, but also it can be made from 5 plus 2. Same thing here now. I'm trying to go, like if anybody had a little confusion with the second one, I think it's fair because we're asking something different now. And the thing is, this different thing I think is also possible. Like the nature of time and space don't preclude it. It's just a different thing, which is having something here and then having a different thing at that same here, but later. I don't know if that's cool. So let me just look in the chat and I'll go, let me just hold on. Oh, now that is very, and I'm glad I'm actually really pleased that Lars is holding his ground. To tell you the truth, I think that's a very very important and reasonable. I wasn't thinking of that, but that's all at this moment. But what Lars is saying in the chat, sorry, I should be out loud. And definitely he should submit this for participation, like you all should. But please remember, there's at least one portal that specifically gives you 75 points if you say something that even someone might have said was wrong. Like you get more. So, but I'm not even. But it's not that he's saying anything wrong. Lars is saying, yeah. No, it did. The homework did say the same. Okay, so Lars is saying, I think it's impossible because we are constantly moving through space. And also only because the homework said same place. Oh, wait. Right. Okay. And I really do want to, I don't mean to cut off debate prematurely. I didn't even mean to give an answer to this one, just I thought. But I want to address what Lars is saying. Lars is raising a very important objection. And by the way, he's right to read the question carefully. Like he's taking the words of the question extremely seriously, and he should. Like I think that is fair. But all right, so but now let's address this. So Lars is raising an important point, which is, yeah, I believe we're all standing on an earth or like as we do this activity, we're like on an earth. And I do believe, for various reasons, including being told, I don't know if you believe this or not, but I do believe the earth is moving past the sun like all the time. I do believe the earth is orbiting the sun. Now, yeah, I mean, I don't think it's obvious that it is. I think we could get into a whole big discussion about why we believe that it is. It's kind of weird because we don't feel it, but we do believe that the earth is moving past the sun. And in fact, I do believe that. And in fact, I believe that it's doing that always while it rotates on its own axis. And for what it's worth, the rate at which it's moving past the sun, I don't know, like this is a big deal in physics 1 to me, a big deal. I don't know how much any of you have thought about this because I didn't have you for physics 1, but like, when we say the earth is moving past the sun and yet we say we never feel it, like we look down, like when I jump up, I'm not afraid of the ground slipping to the east out from under my feet. And then when I fall down, landing on a different spot or something, right? Or like when I think that the earth is moving, I don't think that when I jump up, I'm going to land in a different spot, or I'm not always worried that I'm like falling to the east all the time and getting sort of nauseated and wobbly to the west or something. Like there's this way in which we all say that the earth is moving all the time, and yet we never experience any direct sensory evidence of that. So some people, and that's very interesting, some people will say, oh yes, I guess it's because the earth is moving so slowly. Well, maybe that comforts them to say that, but just for the record, the rate at which the earth is moving past the sun all the time, if you believe any of this, if you believe the earth is moving past the sun, like in an orbit around the sun all the time, then you can look this up. Like the rate at which we're doing that all the time is approximately 65,000 miles an hour. I mean, that's freaking fast, yo. I mean, like that is faster than escape velocity for a rocket ship. Like a rocket ship, to make it to Mars, doesn't have to go fast, blasts off at like 45,000 miles an hour. We're saying that all of Earth itself, the mother ship, is perpetually traveling at 65,000 miles an hour, like on average, like sometimes a little bit slower, but a little bit slower means like 64,000. It doesn't mean like 5,000. So the Earth is always going at like 65,000 miles per hour past the sun. By the way, the sun itself, I'm not saying is sitting still anywhere. The sun itself is going past what's called the galactic center, the center of the galaxy, at speeds that are upwards of like 630,000 miles per hour. That's what the sun is doing, past the galactic center, while the Earth goes past the sun at 65,000 miles an hour, while it rotates on its own axis at like 700 miles per hour, like close to the speed of sound. All of that, I believe, as like a person and a physicist, and I believe Lars is absolutely right to raise it. Like we can't ignore that in a physics class. In fact, the whole purpose of this entire class is to get us to believe by the end why we think, to get us to understand by the end of this class why we think the universe is expanding all the time. So I sure as heck do think it's legitimate, like more than legitimate, for Lars or anybody to bring up, hold on, isn't the Earth like moving, yo? Very fair point. The Earth is moving. So here's where I really agree with Lars, and I'm trying to be as fair about this as possible because it's really, but important point. I think the Earth, I don't know why I believe the Earth is moving. I think it's I think we better talk at some point, like why we do believe in that, because it's weird, but it is true. It is true. So if the Earth is moving, then Lars is right. When I hold up this Coke can here, like at this spot, right? And then I want to, at some other time, put my pencil in the same spot as the Coke can, I do think that Lars is right, that this is going to be a bit of a trickier exercise than I might have hoped. It is true. If I just go like this, and then I go like this, I think that depending on my reference point, if we're saying point in space in relation to like the sun, for example, if like the origin of our coordinate system is like the sun, then I think Lars is right. Is right that when I go like this with my Coke can, and then I try to put my pen in the same spot as the Coke can, during that time, the Earth is moved past the sun. So if I'm thinking that I'm going to put my pen in the exact same spot relative to the sun that the Coke can was a minute ago, I would be kidding myself. And again, and Lars is right in that sense. And in other words, what I do think, like my little gesture, and notice I didn't ask any of you in the class, dude. I just did the gesture this time of like going, blah, blah. I agree with Lars that gesture actually is a little bit crude. Like I can't really guarantee that my second object is going to land in the same spot as the first object if I mean same spot relative to the sun. First of all, yes, that's true. I can't guarantee that. But now here's my response to that though. Number one, I don't know if by spot we meant relative to the sun or relative to Earth or relative to something else. It's a fair question to bring up that all coordinate systems need origins and all velocities need reference frames. So it is true that if I say same spot, I better be careful what reference frame I'm in. Do I mean in the reference frame of the sun or the reference frame of the Earth? And that will make a difference. But then I can specify, and once I specify, I think I could behave according to that. What I mean by that is my second point, and that's this. What Lars is definitely right about, what's really important is it's actually harder than it looks to make my second object land in the same spot as my first object. But that's also not quite what the question says. The question says, is it possible or impossible for the two objects to occupy the same spot at two different times? So what I want to say now, and again, I'm honestly totally hope this is all out of respect for the objection, and I think something would be wrong. I would be disappointed if we flew through each one of these examples and no one had any objection to anything. Like something would be wrong. They are meant to be discussed. So it's with total respect that I'm saying all this, but I will say nonetheless at the end of all that if the question is it possible for two objects to occupy one spot in space at two different spots in time, then I'm going to say yes, even taking into account the motion of the earth. I say it is possible, because the question isn't asking me, is it possible for me to guarantee it in a 2-minute, like it's not saying, is it possible for you to make sure that the second spot you put your object in is the same as the spot of the first? It's just saying, could the two spots ever be? I'm sorry. It's just saying, could the two objects ever be at the same spot in space at two different times? Like, not for my planning. It's not saying, could I make it happen when I want to, or can I like show it on command? It's literally just saying, can two different objects occupy the same spot of space at two different spots of time? And I want to say, yes, it is. Like wherever this cocan is right now, whatever this spot is in space, relative to the sun, relative to the earth, relative to whatever origin we decide, I believe that this cocan can leave that spot, maybe even just because it's on an earth that just moved that spot. Like the cocan might be moving away from that spot even just right now while I'm sitting here, according to Lars. And that's totally cool, true. But the question is, whatever that spot is that I'm thinking of, could anything ever else ever occupy that spot? Or has that spot been like retired fully by the occupation of this object? And everybody might say, oh, well, if that's what you're asking, Yaverbaum, well, duh, obviously, like, and Lars might very well be saying, well, yeah, but that doesn't seem like a very interesting question. Like, I assumed you were asking something interesting, Yaverbaum. So, like, I wanted to go to interesting places, like the Earth moving. All right. You're right. This is not, I mean, I don't know what you're saying, but I'm saying right now, let's not even try to make the questions too interesting. Let's just see what the whole package does for us at the end. I am, in fact, trying to ask the most uninteresting version of the question in a way. In fact, let me write that and then I'll shut up. Hold on. Where'd my pen go? Hold on. I'm literally just trying to ask in each step, could these objects occupy space and time in that way? Could space and time be occupied by these objects in this way? Right now, I'm saying, even given the motion of the earth and everything, I think the answer to the first two tasks, I'm just asserting, I'm saying, but again, I'm saying it's partly all the more interesting and important because of the discussion that's prompted by Lars's and other people's comments. I'm sorry. But I am saying for the moment that I think both of these categories are possible, but they would require a different demonstration. One might be harder to arrange than the other, but I think they're both possible. And and I'm going to look at the chat in a second. And I'm interpreting, I'll write this out at the end. Of course, this is all tricky. Like, look, if I gave you an exam, cold, blind, and this was like a big question on the exam and you had not thought about this before at all, I would think that'd be very unfair, because it is unfair. I mean, it is hard to know exactly what I'm looking for in a question like this. And that's why we're doing it as a discussion. But what I'm looking for is actually a low level, just like common sense interpretation of these questions. And I think that's going to be worth it only because I think we're going to find that even with a low level interpretation, like a straightforward interpretation, we're going to find that some of these tasks are not possible, like that there is a contrast, and that's what makes the whole question worthwhile. If I define things so that everything we do I would call possible, then it would like be really stupid, and I think that unconsciously some of you might be worried with that when you're doing a homework like this. You might be thinking like, this is too dumb, like this can't be what he's looking for, like, but no, indeed, I am that dumb. All right, so I think the answer to the first two so far is possible. Now we get to the next one. But again, possible with an asterisk if you like. Like, I totally get why someone said impossible. But now we get to the third one. Now we have right. Okay, so that was and I never read. I'm sorry, I never read Gabrielle's thing. Wait, I'm sorry. Oh wait. Sorry, wait, I'm just backing up and being in chat now. But this is the question for 3, and feel free to put anything in the chat for this question 3. We're now asking question or task 3, but I'm just catching up and reading. Oh whoa, what? We're on a roller. Yeah, no, we really are. It's a very fast roller coaster for reals, yo. Oh yeah. Right. That's good. Hold on. Sorry, I'll just respond to these private chats. Oh, that's fine. Huh. Okay. Okay, wait. No, this is great. Now, oh, sorry. Okay. This is great. We're looking at question 3. Now, what's happened here is a sort of a typical physics thing like, oh wait, no, I'm still reading. Hold on, sorry. Oh, interesting. Right. No, you guys are now saying some real things. And they sort of maybe sound philosophical, but they really are physical, what you guys are saying. And oh no, this is good. And let me say, I'm particularly, if you're thinking it all like you think you get it, but now based on all the technicalities and nuances of number 2, you're less confident. That's fine. That happens in physics. In physics, we gain wisdom at about the rate that we lose confidence, if that makes any sense. Like you don't get more and more confident as you go in physics. You get more and more humble. But yes, please. I would love to have Lars talk. Yes, because I've been talking about it forever. Yes, Lars, take it.
Okay, so my idea of this, like I think it's impossible, right? But when you brought up the issue with the Coke can, right, and it could be any space, like the point of origin could be like anywhere in the can because it's not the actual can itself. What if I had two bottles and one was just bigger than the other, and then both middles were the point of where I was looking for? So if I put the smaller bottle in the bigger bottle, technically the both points are at the same space.
Oh, no.
Right? So like, because they're also not occupying each other's space either, because the whole bottle itself isn't inside the bottle, isn't like overlapping with the other bottle. They're just simply inside one another. But the point of origin, what we're trying to find, uh, at the same place, are on the same point, almost like a graph, right?
I totally hear you. No, that is yeah, that is a good one. I totally get what you're saying. And that is, all right. So now, and I'm totally glad you said it. And again, this time I'm not saying right or wrong yet. Like I haven't said an answer to this number. I think 3 is controversial now. And sorry, Kat, you might as well just talk. Yeah, actually, you guys talk. Like what you all heard what Lars just said, and Kat, you want to respond? You feel free to respond, and because I'm definitely not saying the right answer yet on this one. So, and I definitely do want to discuss this. So yeah, so Kat, respond to Lars.
Yeah, no, that's a really good point, and like I completely agree. But I feel like for instance, like if you're looking at a graph and like you had two different lines, like two different vectors, and both of them started at the origin, it would still be two separate lines, right? So like they would both start at 0, 0, but it's still technically two separate lines. So I feel like it would still be two separate like points essentially, if that makes any sense. Like I'm trying to get like a visual, but
Yeah.
I think I kind of understand, but my idea is like, because they're both like you can choose practically any place within the bottle or whatever item to be the, like, I guess, point of reference, right? So I can just like put one bottle inside the other as long as like their physical forms are not overlapping. The origins can still technically overlap, right? So like I can just have like a massive container and a really small one, and the small one's just on like 0, 0, and the bigger one's middle is just on 0, 0. So technically, both centers are at 0, 0, right? Even if it's like an XYZ graph.
But then at that point, how could they be distinct? Like, wouldn't that just be the same point?
Yeah, isn't that the argument? If both points can be there at the same time, because it doesn't. Because like if it was like physically a total object, I suppose maybe not. Because that's explaining the entire physicalness of like the object. But if it's like just a particular point in an object, right? So technically that could work unless we have to be like the actual inside the actual object itself, because like the bottle's inside its air or water or something. So I guess it wouldn't have a point in the physical bottle. But if the middle is like the Coke can, if the middle of the Coke can, just like the center of the empty Coke can is technically the middle, I can fit something inside that or fit something outside that.
This is great. This is not off the topic. This is the discussion. Like this is worth, and I promise you that even if there's like a right answer or something, sort of, definitely both sides, like what Lars is saying and what Kat are saying are both, to say the least, they are both legitimate enough to be worthy of being said and heard. Like I want to continue. I don't want to weigh in yet until like Veronica looks like was saying something about, I want to keep with this for a little while. This is worth hashing out. So I think it was, oh, wait, sorry. And in terms of what Veronica is saying, and then Gabrielle, and again, I don't want to cut off the discussion. I think there is a resolution, but I don't think it's an obvious one. And so one good question of clarification was Gabriel's, which is, yes, if we're trying to be as broad-minded about this as possible, we can picture X, Y, and Z. Like, I think that is a fine question and a fine thing. Like, just like in a way, Lars's other question sort of opened up the discussion to, are we actually including all of space, or are we like just here on Earth? And I'm saying, no, he's right to say we can include all of space. And similarly here too, like Kat's thing about the graphs and like two different curves that intersect at the origin, but are nonetheless different curves. Like that does raise, like, that's another way of raising a similar question, which is, when I ask you guys about space, when I say there are two objects at the same point in space, am I taking into account like X axis and Y axis and Z axis? And let's say that, yes, I am. Like, yes, I am. If that I am. I'll say what I think we have so far here. And again, I want to continue the discussion. I don't want to cut off. I'm nervous about that. But on this question number 3 of 2 points of mass being at one point in space, at one point in time, what I think you guys are saying so far is, until the bottle inside the bottle example, like Lars is raising bottle inside bottle, in effect, or like something inside bottle. And he's raising it for a very good reason. Like, I have to tell you, this is definitely, like, you can't figure out this whole sheet without someone raising a thing like that. Like, that's an important thing to raise. And I'm going to call it bottle in a bottle for the moment, right? The question that he's raising is like, does that count or not? And Kat is kind of saying, well, she didn't think at first that it should, but she sort of sees that maybe, but we're trying to discuss whether something inside something should count or not. Let me at least say that if that's what we're discussing right here, it seems like we then are discussing that because we're all comfortable assuming that if we don't go to that level, if we don't construct this interesting example of something inside something else, then it seems like I think most people are saying, well, then it would be impossible. Right? Like Lars came up with this example for a reason, because this really does test the boundaries of the question. But if we don't do this example, if you're just talking about like a closed Coke can and a pen, I think we're all saying, unless you cleverly put the pen inside the Coke can, you can't have the Coke can and the pen like occupy the same place at the same time. I think that's what people are saying, that they're saying they're not too worried about this question until we start putting things inside other things. And then the question is complicated. I mean, is that am I right to, let me look at the chat. Hold on a second. Oh, okay. Right. No. And so as far as what Kat wrote at the end of the chat, like, I'm not saying yet that it's resolved. I am not saying definitively the bottle in bottle example proves or disproves anything. But I'm saying I think it's being raised because I think you all, are willing to agree outside that example. Like, you might even still agree inside that example. Like, the example might end up not changing anything. And that's kind of what Kat is saying, that even that example is not powerful enough to show a problem here. But I think it's on the table because it seems like everybody seems to agree that we would need an example that powerful enough to show possibility. Otherwise, the thing seems impossible. I think that's what people are saying. But let me. Okay. Right. Okay. Liquid. Sure. Right. Okay. So right. All right. That's good. So Lars is saying to the group, like, all right, he's saying what if my two objects are like a bunch of Coke, like liquid, which is fine. I never said something couldn't be a liquid, totally reasonable. So he's saying, what if one of my objects is like a bunch of liquid, this Coke, and my other object is a Coke can. So if I put the Coke inside the Coke can, don't I now have the center of the Coke being at the same place as the center of the can? Like that's what he's saying. Super reasonable example. And honestly, I would maybe even say even more difficult to argue against than his Earth example, which was also good. Like I'm not saying the discussion's over, but I'm saying it's a worthy example. It kind of forces us to really ask what are the definitions that I'm operating with here with this question. So I'm just going to say it one more time, then I'm actually going to walk out of there for 2 minutes just to let you discuss, you got however you want. But the question is like, well, the original question is it possible for 2 points of mass to occupy 1 point in space at 1 point in time? Like that's what we're asking right now. And I think that we're saying so far is like, well, if the 2 points, if the two things are very straightforward, uninteresting objects like a can and a pencil, it seems like we're saying you can't have a can and a pencil occupy the same point at the same time. Same point of space at the same point in time. But then we're suggesting here, we're asking, okay, but what if your two objects are a bunch of Coke and a can, and you put the Coke inside the can? Then do you have two objects, then do you possibly have 2 points of mass occupying the same point of space at the same point in time? I think that's the question on the table right now. I'm gonna walk out for like 2 minutes just to if you guys can discuss in some kind of way differently if you think that I'm not listening to you, and also because I'm going to use the restroom. So I'm going to walk out for like 2 minutes, but I don't think we've resolved the question. The question is possible or impossible. The question is, what do you do with the Coke inside the bottle question? I'll be back in 2 minutes.
How small or how big is the space? Because let's say how big the space is a building, then two things can occupy the same space. But if it's as small as an atom, and in like in an XYZ graph, it would be the same as like the water, let's say, or the liquid inside the Coke would be 0.0. Like that would be the space, but then the bottle would be 0.1, and so technically there'd be two different spaces, even though like they look like they're occupying the same space.
That's a good point. I mean, I was assuming that it was atoms, like very, very, very small. So like with the liquid example, I mean, because since liquid is obviously like very like flowy and more viscous than solid state of matter, I feel like it would still be difficult for like an atom or like a molecule of like the Coke to be in the exact same point. Like that specific molecule of Coke to be in the exact same point at the exact same time as like the center of Coke. It could, I guess, but I feel like it would just be like such a small chance that would occur. But yeah,
I agree with you.
Yeah, it depends on like the parameters of the question, which is like why this is interesting. So
Yeah, I think it's like if it's talking about atoms and like particles, like physical things, then yeah, I totally agree with you. Like it's not possible because they're in, it's the exact point. But if it's just like an idea, like I was assuming it was just an idea because he said center of Coke can, so like it doesn't have to be the physical Coke can. Then possibly speaking, we're just thinking about it's just invisible, kind of like any point in general.
yeah, I even said in my answer to this, I said it was impossible, but then I said like maybe with other states of matter, like I don't know. So yeah, this is definitely like an interesting one.
Yeah, I mean I said impossible as well, but I was just like starting to think now like that he brought it up, and I was like, oh wait a minute.
Yeah, I like the bottle in a bottle one, but I was also thinking like because I was like looking at this glass and like the straw, for example. So like it would still not be in the exact same point because like the bottom of the glass would like push up the straw. You see what I'm saying?
Well, what if it was like hollow? What if the glass was just like a tube now?
Yeah, like it didn't have
Like-
a bottom. Then yeah, that would be an
Yeah, so
exception.
like that's what I was imagining. Like, okay, I'll show you. I have a big water bottle and then a smaller one. So like if I just somehow got this in, sorry, it's like hard to see. If I somehow got this one in here, technically both points are at the same spot,
Yeah.
right? But like, I mean, I don't know. I'm not, there's no way I can get them inside without like opening them. But That was my idea.
It becomes like the same premise as if you cut a piece of lasagna and then cut another piece of lasagna and then put the first piece on top of the other. Do you have one piece of lasagna? It's like the same thought process.
I don't know, but now I want lasagna.
I guess you have a really tall lasagna.
I didn't hear anything after you said lasagna. I was like,
Wait, technically maybe not, because isn't it lasagna supposed to be constantly layered? So then you'd have a layer on a layer, right? Because it's the bottom layer and the top layer. Unless you have like the bottom of your lasagna is just like sauce. So technically you still have two lasagnas, unless you remove like that layer of like pasta kind of thing.
Oh my God. All right. Did I
Right?
mention how much I love this class? Wait, that is awesome. All right, wait a second. I came back in the middle of, so I heard you guys talking. I didn't even want to come back because I loved the talking. I don't want to interrupt it. Then the lasagna thing happened. All right, wait. First of all, now I'm totally hungry too, but this is hilarious. I think you're all onto something. I also noticed, by the way, wait, what is it that, wait, so the question got so inspiring that not only is Lars saying all this cool stuff, but Lars even goes video for a while in the middle of discussion. I'm so thrilled, but then I start talking, the video goes down. It's totally tells me, oh, all right, that's like 1,000,000 points right there for everybody's getting 1,000,000 points just for that. No, yeah, I mean, that's awesome. And I'm not trying to force it. All right, I'm not going to push my luck, but yes, it's great. I feel like I'm getting to know this class even better now as a result of this. Any minute somebody is going to actually like not only put someone this is going to turn into a cooking class. We're just going to cook for each other and eat lasagna stuff. But before I even resolve the thing, but I'm glad, no, your guys are right to argue about this one. There's a reason we're doing this, and it is the right arguments that you're making. I will do try to resolve it in a second. But your lasagna thing also reminds me two other similar points. One, George Carlin, the comedian. I don't know if you know the comedian George Carlin, if he's still away. Yeah, bring a side salad. That's hilarious. Please do. Yes. But George Carlin used to say, you can donate to my Venmo. All right, that's awesome. That is, by the way, the weirdest thing about Venmo is how it always says like, oh, Dan Yaverbaum just paid Jesse Yaverbaum $10. And because it doesn't say the 10, but I find that so bizarre that it does that. But okay. Yes, wine is allowed. And if not, you can turn the water into wine. And if you don't have any bread, you can turn the fish. Okay. Olive Garden. Okay. Oh, and don't start with Olive Garden. Well, anyway. All right. This is getting crazy now. But George Carlin did say that what did he say? He said something was like crumbs. I forget what it was. Oh, thingamabobbers, or like crumbs. In that a crumb, if you got a crumb on the table and you chop it in half, if you have a crumb on the table and you chop it in half, you don't have two halves of a crumb. You have two crumbs, right? Similar to the lasagna thing in a way. And also like the lasagna, someone once told me, someone was once taking a computer programming class like years and years ago, and they were trying to teach like recursive structure, if that means anything. And the example that came up in this computer class, it doesn't matter if you know about computers or not, but the funny example they tried to teach was in trying to teach this recursive method of programming, they said, and this is like the lasagna thing, and I'm just going to spend it this, I don't know, I think this is worth it. The instruction that was given in this computer programming class, again, kind of as an example, and again, years and years ago when everything was different and there was no viruses, the idea was, all right, imagine the following instruction manual for how to build a wall. Like this was the idea, like imagine that you have to build a wall, and here's the instruction manual. The instruction manual for building the wall says, step 1, lay down a row of bricks on the ground. Okay, so step 1 is lay down a row of bricks. Step 2, put a wall on top of the row of bricks, right? So this is an instruction manual on how to build a wall. And the steps are put down a row of bricks, step 1. Step 2, put a wall on top of the row of bricks. Now, what is that? That's insane, right? Like that doesn't make any sense. If you're being asked to tell someone how to build a wall, you can't say step 2, put a wall there. Like what? But that kind of does make sense in a weird way, because the idea of this instructions is, okay, I don't know how to build a wall. I don't know what a wall is. And if someone says anything about wall to me, like, I don't know, I have to look up an instruction manual. So I'm looking at my instruction manual, and the first step says, put a row of bricks down. Okay, I can do that. So I put a row of bricks down. Okay. And then the second instruction says, now put a wall on top of that. Now, I don't know what the hell that is, but I'm like, what's a wall? Oh, I better read the instruction manual. So I go to step one. I'm like, how do I build a wall? I don't know. It's asking me to put a wall. So I look at step one. Step one says, put a row of bricks down. So I put a row of bricks down above my second row, right? I mean, above my first row, because I'm following instructions. And then it says, put a wall. And I'm like, well, I don't know what a wall is. So I read the manual and it says, put down a row of bricks. So I put down a row of brick, right? And this keeps going on until I'm super frustrated, of course. And I'm like, this is insane. Like, I never learned what a wall, it's never telling me what a wall is. It keeps sending me on this mad goose chase, this like loopy, self-referential thing. And it's totally stupid. So eventually, after about 6 of these, I'm not crazy. I get that I'm not getting it. So I give up and I walk away. And I say, forget you. I'm not following this dumb instruction anymore. I walk away. And what do I have when I walk away? A wall, right? You see my point? I'm not even sure what my point is exactly, but it's like a weird, I mean, in fact, that will bring us back to the class. It's a weird thing how feedback loops actually shouldn't work at all, but they do, is kind of what that's saying. And it's kind of related to the bottle in the bottle thing. Now, what is, I don't, oh wait, I better look in the chat. I'm sure I just fired myself. I'm sure that all that did was make everybody hungrier. Hold on. Yeah, right. It's hungry. Yeah, it makes you repeat. Right. So it's a clever, right. So now what does that have to do with anything? I love this discussion that just happened. I feel like I know everybody much better, blah, blah, blah. But what do I think the answer is? I think that I hope I didn't just break my pad. Oh, what's going on? Oh, did I just break my whole pad? That would be interesting. Pardon me for a second. Hold on. Jeepers. This thing is so broken that I'm actually saying jeepers. Wait, excuse me. I do not know what to do. Okay. Okay. If this is the question, now again, and again, this is meant to gender discussion. It's a homework sheet. It's meant to be a friendly thing. Like really, it's important always. It's not really about who says what or who is right or wrong or anything. It's really just about what we ultimately think the answer is. So we're picturing these objects on our table and we're trying to think about things like Coke cans or not Coke cans or lasagnas or not lasagnas. But if the ultimate question here is, can 2 points of mass occupy 1 point in space at 1 point in time? Like, just like the other 2 questions were, can 2 points, like the first 2 questions were, can 2 points of mass occupy 2 points in space at 1 point in time, or 2 points in time at 1 point in space? If we're now asking really, basically, as far as we know about space, time, and matter, can 2 points of mass occupy 1 point of space at 1 point of time? What I want to say ultimately is that the very, very smartness of Lars's example, and the very fact that Lars had to come up with that example in order to really push this question, and it really was smart, and he really did have to do this, actually shows me something subtle about space and time. It shows me, and I don't even remember who this is agreeing with or not. It doesn't matter. Everybody's view is evolving. But it seems to me that what the whole Coke inside bottle thing actually shows is that there's clever stuff we can do. But actually, even to try to show the possibility of this, we end up showing the impossibility, because when we put the Coke inside the bottle, the whole cleverness of putting the Coke inside the bottle, and I know, and this is exactly like I think why Lars came up with it, like the cleverness of that is that the point in the center of the whole bottle and everything, that point in the center that Coke is now occupying, and again, that's what's making it a good example, that point in the center of that bottle is a point, and I did ask you to think about it, but it doesn't contain mass, right? Like that's why it's a bottle. Like the fact of it being a bottle, a container, the cleverness of it is that we hollowed it out so that we could put some other stuff in, right? The cleverness of it is that we created a shape where the very center point of it doesn't have any mass, like because it's a container, it's not a contained, it's not like a solid object, it's like a vessel or, you know, a shell. So, and again, this is not saying anybody's saying anything wrong. It's not saying anybody cheated, but I'm saying like the power of his example is when you think about it, that Coke bottle, it has a center for sure. It has a center point, but there's no mass at that center point. That again, that's why we can put things in that bottle. So when we put Coke in, there's some Coke molecule perhaps that's at that point, but there's no bottle molecule that's at that point. That's why we do it, why we like to do that. But it's showing it works because in fact we could put the Coke there only because we could put the Coke at that spot only because there isn't glass at that spot. Let me be one more way specific for a second. Again, and this is not about anybody being right or wrong. This is just about a point about space and time I want to develop. Go a step further and say, let's really think about liquids, because it really is clever that we not only brought up bottles, but that we brought up bottles that have liquids in them. Like, let's talk about what if my two objects are like Coke and ice? Like, what about I have a glass of Coke, let's say, right? And now I have a glass of Coke and the Coke is everywhere in that glass. And now I want to take a hunk of ice and put it in the Coke. Like this would be an extension of Lars's example, or like an even, you know, a further elaboration of the example. And it really seems convincing to me now. Like it doesn't have to be Coke, like it could be water, right? But I'm saying ice, maybe you don't like ice because you know ice floats. Okay, it doesn't have to be ice, it could be a marble. Like I take a marble and I stick it in my glass of liquid. So now I really feel like, oh boy, I'm taking the center of this ball and I'm putting it in the center of that liquid. And boy, this like the point of this ball is going to occupy that point where that liquid is. But you all know, you know where I'm going with this. You know what's going to happen, right? Like the water level is going to rise because of what we call water displacement, right? And even whether we're comfortable with the numbers and the quantification of the details of that or not, we all know the water level rises because when I stick that marble into the water gets out of the way. Like it's like a third grade principle, but it's actually a really deep principle. It's that like literally even with liquids and frankly, even with gases, as it turns out, like that whatever atoms are composing, whatever particles are comprising that liquid, they cannot be in the same space at the same time as the atoms and the particles that are comprising the solid marble or the solid hunk of ice or whatever. So literally, if there's a bunch of liquid there and I put a solid in, the liquid clears out of the way because they really won't share a spot. Like, and again, so I guess what I'm saying is, first of all, I'm saying that this third one is impossible. And again, I'm almost intentionally not even looking at the chat yet or whatever, because what's dangerous always about these discussions is then it ends up sometimes looking like that we care like who's right or who's wrong or something. And it's totally not about that. And of course there's ways to, and a lot of it is about how are you even supposed to be interpreting the words of my question? Of course, that is a challenging part of this. And in fact, all of this whole exercise is meant as a secret way of giving you some definitions now to work with from here on, to show you how slippery these definitions can be unless we nail them down. So what I'm really trying to, there's ways in which I could understand this third task. There's ways in which I can interpret the word where I would say possible. And there's like other ways I could interpret the other questions differently. But if I'm trying to be consistent, if I'm going to try to interpret each one of these tasks with the same understanding of the words and the same intuition in mind, then I would say the way in which the first two tasks can be easily accomplished, like or somewhat easily, like you can go like this for the first task, or you can go like this or something, and then wait for the earth to do it for the second task. The third task, there, even with a bottle in a bottle or a bottle with Coke, it's intuitive. You have to do something very contrived or very like quantum mechanical or very like beyond the scope of anything that like we're familiar with in order to really pull off number 3, I think. I'm going to be more specific about that when we get to the end, but I guess I'm claiming right now, so we can move on or whatever. I think that with the soft, intuitive definitions I'm holding in my mind of how to interpret this sheet, so far I'm saying possible, possible, impossible. I'm also saying that when we get to number 5, I will give you concrete definitions that I think all of these lead to that can make the whole thing self-coherent and self-consistent as possible. But let me just look in the chat. Sorry. But I think it's possible, possible, impossible so far. Oh, cool. I think I don't know what IYKYK is, but I guess someone will tell me. But okay. Oh, people are laughing. Oh, now I'm seeing. Oh, now I know why you don't show your videos. Now I'm seeing the laughter. I'm so embarrassed. Okay. Well, all right. I'll figure it out. Well, you'll tell me. So I'm going to go on to 4 now. I'm like very nervous here. You know, you all keep laughing, but until one of you gets a freaking, Mewtwo level 100 for my son, then I don't even know what we're talking about anymore. No, okay. So, oh no, this is task 4 now. And this one is, right. That's right. That's right. That's totally not right, but yes, that's right. If you know, you know. Whoa. Deep, yo. Wait, is the OMG? I'm worried about the OMG. Oh my God. All right. I'm going to keep doing physics. I'm so out of my league with, so 4 is. Oh, wait. Oh, sorry. Number 4, now we switch. Number 4 is 1 point. Okay. So this one, oh. Now okay, one thing. Okay. Oh, on this number 4, which I think I've copied down correctly, and now I'm going to be a little bit serious. Cat's thing, totally reasonable. I mean, Cat is saying in the chat, I said 4 was impossible at first, but now I'm thinking it could be possible if you consider Heisenberg's uncertainty principle. Very fair for her to say that, because again, this is a physics class, and as you can tell, like, you never know when I'm going to say, like, oh, well, guys, now we're talking about the rotation of the Earth, or now, guys, why didn't you like? It's totally fair if you're thinking that, like, physics could be brought into a physics class, such as Heisenberg. I will say that what I'm trying to do is answer these questions. I don't want, there may be a thing called Heisenberg's uncertainty principle, and some of you may know a lot about it, but it's not really fair for me to assume that everybody in the room does know about it, and I'm not going to. So I will say that these questions, what we're actually trying to do right here is like establish some fundamental physics principles for macroscopic classical space. Like, funny things do happen in quantum mechanics. I'm happy to discuss them, but I can't assume that we all are comfortable with them in this. So I'm not even taking that into account. I'm not taking into account Heisenberg or quantum as much as I do. Part of me wants to. So I guess to cut to the chase. Oh, but it looks like, wow, I have a strange feeling that Veronica's last name has evolved into something fast, but maybe not. But it looks like, at least, it looks like there is, wait, is this disagreement? Like, I want to pause. So I don't want to say that you don't have to take into account Heisenberg or anything weird. I mean, this is all weird, but you don't have to take into account any kind of physics that we haven't explicitly discussed here. But even not taking into account, it seems like, oh no, but that is the way you're, well, I don't know what, no, it's fine. I have a last name that's long too. It feels like it's being spelled differently from the way I was, maybe, okay, anyway, no, sorry, okay. But number 4, is 4 possible? Yeah, okay, I think so. Right, there's some awkward wording going on in 4. There's some awkward wording that's very similar to the wording in 5, very similar to wording, but they are subtly different. And it's possible to misread one of them. I think actually, to cut to the chase, so that I don't like kill everybody. Yes, I think it's possible that Kat might have been thinking more about number 5 when she said the thing about number 4.
Yes, I was. Yeah.
Right. Okay. Right. Okay. Sorry. Thank you. Okay. So I will. So to cut. So I think this is what I think. Number 4. Right. I think this one is saying, can you have an object that's like over here at one point, and then, sorry. Yes, I'm saying number 4. I think there's 2 different ways you could do number 4 that you could prove that it's possible. Number 4, you could do this. Say this is my object. Say this white pen, and I keep losing the screen. Wait, sorry. Okay, say this is my object. To prove number 4 correct, I could just do this. Right? I could just like hold this object for a while in the same place. I could hold it here for a full day. So here's the object here at 5 o'clock on Monday, and here's the object here at 5 o'clock on Tuesday. Same spot, 2 different times, right? I could do that. Or taking into account the whole Earth and Lars's thing, like then maybe I have to like carefully compensate for that. But I could have an object sit still, hopefully according to some reference point, or I could take an object, move it away, and put it back. Presumably those 2 would be some kind of examples of 4 being possible. I'm just going to look in the chat before I get myself into trouble again. Oh yeah, okay, cool. Right. That is, yes. So I agree with, so Veronica, like 4 basically says same space, different time. I agree with Quasi. Crap. Well, at least you spelled crap correctly. That's good. Yeah, no, it's easy to misread 4 because it is sort of awkward. It's easy to think that it's saying what 5 says, but then, okay. But everybody, I think, understands what I'm saying now. So I think 4 is possible. Like, right. Okay, so that's 4. So far we have possible, possible, impossible, possible, and then 5. To cut to the chase, I think this is the one, right? This is, well, 5 is 1 point of mass. 1 point in time, 2 points. Right. So the other one was 1 point in space, 2 points in time. This one is 1 point in time, 2 points in space. A very subtle, very small difference, right? That makes it easy to think that the 2 things are the same, but it makes all the difference in the world. To cut to the chase, I think this is the one that's impossible, right? I mean, to cut to the chase. This one is asking, can you have one object, 2 different places? Like the other one, this one is saying, can you have one object at 2 different places at the same time? And if there's one thing that we sort of all kind of sort of know, if there's anything that's not possible in a way, it's that. You can't have something at 2 different places at the same time. What you can have, though, and this is what threw people off about 4, and we're not done yet, but just so far I'm saying out of these 5 tasks, 2 are impossible, 3 are possible. I'm saying number 3 and number 5 seem to be impossible. And let's focus on that number 5 one for a second. Again, 5 is the opposite of something that is possible. Like it is impossible to have all object at 2 different spaces at the same time. But it is not impossible to have one object at 2 different times at the same space. Like that's an incredibly awkward thing to say. People almost never say a thing like that. But but they should, because we're I mean, they shouldn't just go around saying it, but like, think about the contrast. Like, we are saying something about space and time. Something is emerging. If that sentence works in one direction, but it doesn't work in the other direction, you can't, like, space and time are very similar in a way. I mean, this is where the rest of the sheet goes. Like, they're both continuous. They're both infinite in expanse. They're both infinitely divisible, which is the same thing as continuous. They're both like super basic. They're both the same everywhere. Like, whatever space is over here, it's the same thing as space over there. Same thing with time. Whatever time was then, time is tomorrow. But then they're incredibly similar. So similar that we can make coordinate systems out of like space axes and time axes. We can treat time axes almost as though they are space axes. In some ways, space and time seem so much like similar playing fields in which masses play, and we call that physics. But on the other hand, there's something different about them. There's something different. What's different? One difference is you can have an object at two different times at the same space, but you can't have an object at two different spaces at the same time. And also, similarly, like, you can have two objects occupy one space at two times. You can have two, well, let's say this again. So, well, wait, I'll leave that for a moment. So this is what we have so far. This is thank you. And then you can take that for you and feel it. Thank you so much. Thank you. Sorry, talk about food. Okay, we are 6:12. Oh, wait. Yeah, no, that's totally possible. Bending of space. Good question in the private chat about bending of space-time. That's kind of like quantum mechanics. I am going to say things about that toward the end of the semester, but I can't assume that we know anything about that right now. So it wouldn't be fair for me to assume that could be part of our answers here. But also, the truth of the matter is, even with the bending of space-time, whatever that means, this stuff is true. There's some other things that aren't true about it, but that is true. But let me, I'm going to tell you where, well, okay, so. Wait, did we, I'm sorry. I want to write down that space is homogeneous. I think we did this in this class. So actually we talked in this class about how space is homogeneous and time is homogeneous, but space is also isotropic. I think we said this in this class, right? Or let me pause for a second. And actually, I have to go get it. I'll be right. But ask us honestly. I want to know if the word homogeneous and isotropic have come up in this class or not. I'll walk away for a second.
I don't think we did. That doesn't sound like a familiar term.
Yeah, I don't think we did either.
What is your background?
It's just my living room. Why is everyone talking to me like
Shut
that?
up.
I also have the 3 big dudes around the one little person, but I'm not gonna use that one today. Or I can flip it on real quick if you guys want.
This is being recorded. Just remember that.
Oh, you're right.
Just be careful.
Oh, meets Professor. Oh, I thought that was whiskey.
For this class, it probably should be even stronger, but no, it's lasagna. Wait, so what did you stop? Wait, what? Oh, so I didn't. Okay, so that's actually good. So I have not mentioned. All right. So right now, okay. I didn't think so, and then suddenly I thought, but okay. So this is what I'm going to say. Okay, this is actually, so another one of these. I'm saying space, like what is it? I haven't defined it yet, but and it's hard to define. In some ways, that is the whole job of a physicist ultimately, is to come to understand what space and time are. But let's talk about what we know about them first, what properties they have. First of all, we're going to say space is homogeneous, like it's like homogeneous milk, like homogenized milk. Homogeneous means the same throughout, but it means same in a very specific way. Like there's more than one ways that something can be the same as itself. To be homogeneous or to demonstrate homogeneity is to say that equally sized subregions are indistinguishable from each other. That means, like, if I take a cubic meter of space from, like, right here in my apartment, I picture a cubic meter of space right here in this room, I consider it. And I can also consider in my mind a cubic meter of space, take it from like the Sahara Desert or the Andromeda Galaxy or like New Jersey, same thing. A cubic meter of space from somewhere in New Jersey compared to a cubic meter of space somewhere in my apartment, they're identical. There's no way I could know that one space was in New Jersey and the other space is in my apartment. Like space is space is space. I could put different objects in the different spaces and then know things, but space itself doesn't have any markings or features, right? That's like, in a sense, what we mean by space. It's just space. It doesn't distinguish itself from other space. So space is homogeneous in that way. Now, why am I saying this? Well, time is also that way. Okay, so this is a way in which time and space are both sort of elusive and abstract and fundamental and similar to each other, is that time is also this way. You can take a millisecond of somewhere, or you could take a 45-minute excerpt of this class, like 45 minutes of this class discussion, and compare that 45 minutes to a 45 minutes taken out of, you know, the meeting of the First Continental Congress in Philadelphia in 1776 or whatever. The 45 minutes that you compare from that period in 1776 to the 45 minutes today, there's no distinction between those two 45-minute gaps. There might be distinctions in the events that occur during them. Like here, I'm talking, there, you know, in 1776, somebody else was talking or nobody was talking or whatever. Like what's happening might be different, but the time intervals themselves are they're like the only difference between one time interval and another is how long it is. Once you specify how long the time interval is, then all time intervals are the same as each other. This is a way in which time is similar to space in that they're both homogeneous. That's a way in which they're similar. And that's why, by the way, like tasks 1 and 2 are both possible, even though 3 is impossible. That is, you can have two objects in the same space. Sorry, you can have, two objects at one space at 2 times, or you can have two objects at two spaces at one time. You can play it either way because space and time are both homogeneous. However, there is more than one way in which something could be symmetric or similar to itself, or say, like, there are different ways to express sameness, if that makes any sense. And so space is very the same as itself in the way that we just described. It's homogeneous. Any chunk of space over here is indistinguishable from any chunk equally sized of space over there. But space has this other property as well. It's also what we call isotropic. This comes up in chemistry. Isotropic means okay, by this we mean, for example, by this I mean, like, in real space, in space itself, there's no left or right or backwards or forwards or up or down or north or south in space. Like on Earth, there's a difference between down and up because there's gravity from Earth, but that's due to this object called Earth. In space itself, and it could be outer space, but any space, once you remove the matter from it, in space, there's no true x-axis or absolute or objective y-axis, or there's no actual north. I mean, north on Earth has to do with the axis of rotation of the Earth, and like in space, there's no rotation, blah, blah, blah. So all directions are indistinguishable in space. The x-axis, like we can say this is the x-axis and that's the y-axis. And yeah, they have to both be perpendicular to each other to call them, but we could just as easily say this is the x-axis, right? And that's the negative y-axis or whatever. Like no axis, no direction is marked or different or distinct or special in any way compared to any other axis or any other direction in space. But now the kicker, as you might guess, and we're almost done for today. By this I mean, and this is the ultimate, this is where space, by this I mean, forwards is distinguishable from backwards when it comes to time, right? Like this is This is like the one thing we all know about time. It's why we're all mystified by time. Nobody really understands fully what space or time is. And they certainly, if they sort of feel like they understand space, they certainly don't, nobody fully knows why time seems to be different in this way from space. But this is the way in which it seems to be different. Both time and space are indistinguishable from themselves when it comes to regions, but only space is indistinguishable with regard to itself when it comes to directions. There's no real up, down, left, right, forwards, or backwards in space, but there does appear to be a forward versus backward in time. Appear. I don't really know what's really going on below the surface of everything. Like nobody really knows, but so, I mean, we're getting, hopefully we're getting more and more knowledge, but so far as we all experience the world, we experience a space in which forward is just as valid as backward, where there's no true forward or backward. But the way we experience time, there is a forward and backward. And that is a fundamental distinction. In other words, and I'm just going to pause here for a second. In other words, for the first three tasks, there's like almost a symmetry there. Like in the first three tasks, I can have two objects at the same place at two different times, or I can have two objects at the same time at two different spaces. I just can't do both. I can't have two objects at one space at one time, right? So that seems to be a thing about like the space-time relationship can't be messed with that way, but space by itself is okay, time by itself. That's what sort of is happening with the first three tasks. Then in tasks 4 and 5, we're kind of saying now, so the first three tasks are really about the fact that both time and space are homogeneous. But the next two tasks are really about the fact that space is isotropic, whereas time is not. You can have one object at two different times at the same space, but you can't have one object at two different spaces at the same time. That really is to say space is isotropic, but time is not. I mean, it's like different languages for the same realization. Still not done, though. But this is what I'm saying so far about space and time, and we're almost there. I'm going to walk away for one more second. Obviously, I'm having physical problems. So space and time. Oh, wait. Oh, sorry. Oh, yeah. I forgot these were other questions on the sheet too. Right. Sorry. Hold on. Oh, that's clever. The thing that Kat's saying in that. Yeah, that's clever. We could point our fingers in specific directions, and we can't point our finger toward the future. Sorry, I shouldn't be eating. I'm so hungry too. We are going to end soon, but yeah, that's true. You can't really point your finger toward the future. I'm going to say that to my wife next time she wants to make a plan. But yeah, no, yes, that is a good point. I'm going to go one step further. I'm going to go like one more page. We're actually, oh, wait a minute. Oh, cool. Right. I'm just looking at the chat, but that's right. Ooh, wow. Yeah. H2O, good reference. Right. And by the way, yes, no, I'm glad what you guys, and we're going to, I want to do a couple more pages here of notes, but you know, what you're saying about time, and and I will admit too, I mean, I don't know, maybe I am really hungry. We're going to wrap soon because I'm having a headache of it, whatever. I'm getting my own way here, but it is sort of, I'm trying to lay down these things about space and time because I do find them fascinating. They are really important to just do regular physics, but they also are fascinating. Just as a sidebar, or you know, in terms of the comments in the chat about moving forward in time, backward in time, H.G. Wells. You know, if you came away from this whole class with the belief that I, as a physicist, am now telling you the specific physics reasons why time travel would never be possible or something like that, that would be a misunderstanding. I am not, wait, I said it too fast. I am not here to tell you that time travel would never be possible. We can have a big discussion about that, and we possibly will. I have very complex feelings about that, and I've actually written very complex things about that, or attempted to. My mind is not closed on the issue of time travel, and we can really get into some of that if you want at some point. And even what I'm doing today, I'm not trying to say here that we know for a fact as physicists that time travel is not possible. I am not at all saying that. In fact, I do not believe that that is the case. What I'm here to tell you is what we think we've put together about time and space thus far at this stage of physics. And I don't know that any of it precludes time travel. It just doesn't prove it is possible either. But the thing I want to, I mean, really, we should, I think I'm getting a headache right now, but I would love to talk about the possibility of time travel with this group at some point. Like, it's definitely on the table if you guys are interested. But for the moment, what I'm saying is, I'm saying when it comes to things, what we're actually going to find, I'm talking about space and time here. We're interested in space and time, but actually the ultimate purpose of this entire exercise, and we actually are almost done with it, but the entire purpose of this entire unthinky thing sheet is to actually realize what it is that we mean by thing in the first place. Okay. What physics is about, things moving through space and time. Space and time, we're going to spend the rest of our life as physicists in a way trying to figure out exactly what they are. But we better kind of know what we mean by things moving through space and time, if that's what we're going to analyze. Like, what do we mean by the stuff that's moving through space and time? And it's kind of why I started asking questions toward the end of the sheet that were a little bit abstract. And I really do want to have the whole discussion of what you said in other parts of the sheet, but I am starting to lose it right now. So I'm just going to say, when you talk about something being a thing, I mean, when anybody talks about something being a thing, or put in better language, when we talk about something being material or massive or tangible or solid, or, well, it could be a liquid or a gas, but when we think of thingy things, when we think of things, perhaps even as opposed to something like love or justice, which I think exist and which we think about all the time, but we don't necessarily think of as things, right? I mean, like justice or love, or even like the square root of 2. Like, I think it exists. I think it's very, very real. I also think love and justice are very, very real, maybe even more real than a lot of other things. But I don't really talk about them as things. Why? Well, because I have to go again. Okay, what do we really mean when we're calling something material or massive or tangible or solid? What we really mean in the end, if you think about it, is we mean the sort of thing that is restricted by rule number 3 and rule number 5. When we talk about things, thingy things, solid material, relatable, maybe even scientific seeming objects that we think are concrete, what we really mean by concrete or tangible or material is that if we say that two things are material things, we mean they're not going to share a same space at the same time. Or when we call something a thing, we mean it's the sort of thing that can't be in two places at once. Like, in other words, like love or justice, like I believe in them. I believe they're very real, but I don't call them a thing in the same way, because I kind of feel like there can be love in one side of my house while there is the same love in another side of my house. Like, I don't think it's restricted in that way. And I think that love and hate or something can exist in the same moment or something. If there's like someone's having a fight with their sister or something, right? Like they're abstract in some kind of other way. I'm not trying to define love or justice right now. What I'm really trying to do is define things. In fact, let me be really specific. The real word that I'm trying to define now, you were asked on the sheet, what I'm really getting at is what we mean by a particle in physics. What we really mean by a particle sure, you could say it's the smallest blah, blah, blah of the blah, blah, blah. But no, really what a particle is in the end in physics, a particle means something particular. A particle okay, this may be the punchline of this is essentially just about the punchline of the whole thing. What I'm trying to say, actually, okay, is this. I mean, again, I'm just sort of summarizing, and I wish we could have more of a discussion again, but we're not going. When I asked you a bunch of questions at the end about whether things exist or not, or whether things are real or whether they're in science, what I'm trying to get at is this. For something to be discussed in science at all, especially physics, but for something to even come up and be a subject of discussion in science or physics, it's got to first and foremost occupy space and time in a measurable way. Like love and justice, I believe in very strong, like for real. And I also believe hate. I mean, I don't like support hate, but like I believe it exists, right? I think love exists. I think hate exists. I think justice exists. Injustice exists. These things are very important. They might be even more important than anything I could ever name in physics. Like for real, like they might be, but we don't deal with them in physics. We don't analyze love as such, at least at this stage in physics, for basically the simple reason that love, even if it does occupy space and time, it doesn't occupy space and time in a measurable fashion. I can't measure how much, like where love is or how much time it's there. The day that I start being able to do that is the day that it becomes within the realm of science. But until you can measure something, it doesn't mean it doesn't exist. It just means science can't do anything with it, right? So now for things to be part of science, they have to occupy space and especially physics, they have to occupy space and time in a measurable way. Lots of things do that. But now I'm going to go a step further and say, for them to be called a particle in physics or in science, for something to actually be called a thing, a particle, for something to be called a particle, a particular entity, then it not only has to occupy space and time in a measurable way, but it has to occupy space and time in a manner restricted by task number 3 and task number 5. In other words, for something to be called a particle, it exactly has to be that sort of thing that cannot be in two places at once and can't share a place at once with another particle, right? You may recognize this from chemistry, by the way. A more fancy form of this whole idea in chemistry is the Pauli exclusion principle, right? Like two electrons can't occupy the same, there it's energy level, but it comes to the same thing, the same state at the same time. We're saying that to be particular in physics, to be a particle, to be a defined discrete chunk of mass, is to be material, tangible, solid, distinguishable in this way. To be a thing in physics, to be a particle in physics, is to not share space with another particle and to not be in two spaces at once. The reason I have to make a huge deal of this, or a huge deal, and we're just about done, the reason I have to say all this is that the mass on the spring that keeps going back and forth that we're studying so much in this class, that is a particle for sure. The mass at the end of the string that's bobbing around as a pendulum, okay, that is a particle for sure. But those are actually still part of the introduction to this class, to be honest. They're still part of the building blocks of this class. What this class is really about okay, I'm running out of space again, and I'm running out of time, but what I'm trying to say as clearly as possible here, the reason we're doing this whole weird little exercise that ultimately results in kind of a definition of a particle, what I'm ultimately saying is particles are things that are restricted by rule number 3 and rule number 5. Like particles are things that cannot be in two spaces at one time and cannot be in the same space at one time as another particle. That's what particles are. But the reason we're making this huge deal of this description of particles is that there's tons of things in physics that are not particles. There's tons of entities in physics, if you like, or motions or behaviors or phenomena, whatever, phenomena maybe is the best word. There's tons of things in physics that do occupy space and time in a measurable fashion. Like not like love, not like justice. There's tons of things in physics that do live in space and time and live in space and time quantifiably. Like tons of things that we can observe, measure, analyze, and predict, zooming around through space and time in physics. But such things don't restrict themselves to rule number 3 and number 5. Like I can think of many things in physics that can be in two places at once, or can occupy one spot in space at the same time as another such thing. Like there are. And not only are there, but that's actually what this class is supposed to be about. So that's why I'm saying all this. So to be, in other words, So I'm saying so far, there are tons there in physics. There's a whole world of phenomena or items or entities, whatever you call them, that do occupy space and time, can be measured, can be analyzed, can be predicted. In other words, scientifically like real things, but that yet aren't particles. That don't, the reason I'm making a big deal of defining particles, defining points of mass is because, yeah, that's the thing we kind of already know in our life, but actually there's a ton of stuff in the world that doesn't act that way. There's a ton of stuff in the world that can be in two places at once or can be at the same place at the same time as some other thing like that. These things, you could call them waves, you could call them energy, you could call them information, but such things well, yeah. Okay, the upshot of what I'm trying to say is that you might, I mean, I know you know all this, but you might not have thought of it exactly this way before. Neither had I until I did. But like, but I believe in heat. I believe heat flow. I believe in electricity, as in electrical currents or electrical fields or whatever. I believe in magnetism. I believe in sound. I believe in and I definitely believe in light. I believe in a bunch of things that aren't things, a bunch of unthinking things like light or, well, sound is the most concrete example I can give for right now. Sound is like right now I'm talking. If right now, sorry, like right now I'm talking. If right now it happened that someone else like interrupted me or said something at the same time, or if right now you can hear me talking and if you happen to also be able to hear my son playing a video game right now, right? That means that two sounds are reaching your ear at the same time. If I play a chord on the piano, if I play two notes, right? Or if, if I sing and someone else sings, whether we sing well or not, if two notes hit your ear at the same time, like you hear harmony or you hear, right? And almost always is happening. If you ever hear two sounds at the same time, like you don't implode, you don't fall through the center of the universe, you don't like all freak out. Two sounds can be on your eardrum at the same time. And that's not an expression, that's not a metaphor, that's not a joke, that's for real. Or if you've ever worked in a theater, like you could shine a blue spotlight down on this spot and you could shine a red light on the same spot. You can have a red light and a blue light, and you might say it makes purple or you might not, whatever it is. The red light does not chase the blue light out of the way. The blue light does not displace the way the water does if you put an object in the water, right? Like two lights literally can. And I'm not trying to be cheesy and I'm not trying to be technical. Like I'm really saying, if you really think about it, the whole difference between light and stuff is that when you put your finger on some stuff, the stuff moves out of the way, or it bounces back on your finger and your finger bounces out of the way. But if you put your finger on light, light doesn't move out of the way. When you say you can't touch light, what you really mean is you can, if you think about it. Like, you can't touch my finger because you try to touch my finger moves out of the way. But if you try to touch light, light doesn't move out of the way. Your finger's just there. You don't even feel anything because your finger can be there where the light is. And you could certainly shine another light on the first light, and two lights can't be in the same place at the same time. So much so that we might even ask, well, where are the lights? Like, can we even say that light is in a particular place at a certain time? No, maybe not. Maybe we say the light is spread out in more than one place at one time. In other words, whether you want to say that light is a wave, maybe you've heard that word, whether you want to talk about energy or what I would call the flow of information, I would say that there's all these things in physics that are not material, that are not particles, but they are real. And that's actually what this class is about ultimately. Okay, ultimately we're studying oscillators now because you put a bunch of oscillators together and what you get is a wave. And a wave is not a thing. A wave is not something that has to be in one place at one time or that can't be at the same place at some time as something else. It's very different. It's why it's very cool. It's not material. It's abstract in exactly that way. That's what this class is really about. It's still about motion of stuff through space and time. But the stuff that we're studying, moving through space and time, we're studying the same rules, same math, same principles, same concerns, but the stuff that's moving ultimately, and I know we're still talking about oscillators right now, but we are studying oscillators so that we can build waves from them, so that we can build in our minds electrical currents and electrical fields and ultimately electromagnetic waves, which we call light. Like, ultimately, this course is about stuff that isn't stuff, things that aren't thingy, but are still real. This course is not about particles. This course is about the flow of information. And that's the point of this whole exercise. That's really the point. We're still building it. We're building up non-material entities from material entities known as oscillators, but they have to come from somewhere. Otherwise they wouldn't be signs. That's the point of this whole thing. And I know I'm going to stop. I'm not even going to take, sorry. And but you could tell like my nose is running and my body's falling apart. So I think I'm a little bit of a mess. So I think I'm just going to stop there, if that's cool. And you'll talk with Walters about the exam in 2 days, and then from there we'll like start it won't be until after the break. And we'll have a practice exam before then and all that stuff, and we'll start posting materials for that. But that's what I got right now. I'm actually just gonna run, if that's okay. Yeah. Like, goodbye. I'm sorry. I'm falling. I'm gonna go. So, and I'm hungry. You're all hungry. Have lasagna. Have crumbs. Have a wall. I'm gonna go. Bye. I love you all. Okay. I didn't say that, but I did.